Okay, so we are looking at indefinite integrals, okay, or rather integrations. Okay, most of you might be already aware that integration is the opposite of differentiation. Okay, so we're doing everything in reverse now. Okay, so to start off about indefinite integrals, why are we talking about indefinite? Does it mean there's a definite? Okay, yes, there's a definite one which we'll cover later on. Okay, but for starters, we are looking at indefinite. The reason is because, right, if let's say for example, we are looking at y equals to x squared plus 5, or y equals to x squared and y equals to x squared minus 2 over 7. We realize that given this variety of functions, okay, our dy over dx is all the same, right, which is 2x. Okay, and if I want to say integration as the reverse of differentiation, that means that if I were to integrate 2x, I'm going to get back the original form. Okay, but which original form are we looking at? Okay, there is no definite answer unless we have certain clues about it. So therefore, okay, when let's say I want to integrate, which the symbol is a long S, okay, please don't write a fat S like that. Okay, so a long slim one. Okay, so integrating 2x itself with respect to x, which is dx, okay, will actually arrive at, we notice that x squared is always the one that is in common. Okay, it is the constant that is different. So we will always put this plus c, okay, to say that it is an indefinite integral. Because there is no confirmation at this point what the constant is going to be. Okay, so integration sign. Must always accompany with your dx, or depending on whatever variable we're looking at with respect to x. Okay, very often people tend to put integration sign, forget the dx, or they forget the plus c when they integrate. Okay, so that is the idea that we have regarding integration. It is the opposite of your differentiation. So we start with that fundamental idea first. In looking at triad 1, we are given the function y equals to x times x squared plus 9. We want to find dy over dx and state the value of a. So we should not finding it difficult now, given this one. To differentiate, okay, either you do product rule, which may be a little bit troublesome, or you can just simply expand it before differentiating it and get 3x squared plus 9. But since we want it in a specific form, okay, we'll just write it like that. Okay, the question says state the value of a, so a equals to 3. Integrate 3x squared plus 3. At this juncture, we don't have any skills in integration yet. Now we don't have any rules applied. Okay, we only understand integration as the opposite of differentiation, and this concept itself is very important because very often you need to apply this idea of it being opposite to each other. Okay, so to integrate your 3x squared plus 3 dx, which is actually this dy over dx over here. So from here, if I'm going to integrate, I should be getting it back to its original form, which is x cubed plus 9x. But the thing is that it may not always be x cubed plus 9x. We know that there can be constant itself, just that in this particular case it is this one. Okay, but when you look at integration on its own, we must accept the fact that there is that constant and hence we must put in that plus c. Okay? Oops, sorry. Either you can put this or you can put the factorized form. So regardless of the context, even if in part A they gave it to you in this manner, where we integrate, we must recognize that there is always that constant that we need to add at the back. First rule when it comes to integration. Okay, we know that if, let's say, as an example, okay, if y is equals to, let's say, 3x squared, when I want to differentiate, what we will do is that we keep the 3 on the outside, x our power bring down, okay, then power minus 1, right? Sorry, let me just, okay, let's not do 3, okay, let's just do x squared. Power bring down x, power minus 1. Okay, so that we will get answer to x itself. Okay, we recognize integration as the opposite in this process. That means that if I want to get 2x back to its original form, that means our power need to add to 1, okay, and we need to divide away the 2. Agree? Okay, because when we did our differentiation, we minus 1 to the power and we multiply a 2. So in the reverse, we need to do the reverse of plus 1 and divide away the 2. Which explains why, okay, in integration, if I'm integrating x to the power of n, our power will plus 1 and I will divide away the constant. Okay, because over here I multiply, so in integration I need to divide. Right? So it is reversing now. Okay? So differentiation minus 1, multiply. Integration plus 1, divide. Okay? So look at some examples. Okay, so let's look at integration of x to the power of 4 with respect to x. Okay, so what this will mean is that our power will plus 1, so becomes 5. Okay, and then divide by the power itself, okay, the new power, which is 4 plus 1. In other words, there will be x to the power 5 over 5. But we must remember the constant, so always remember plus c. Okay? Because we do not know in its original form whether there's any constant or not. Okay, and what if I want to integrate 1 over x to the power of 4 instead? Okay, how will that look like? We do our indices law to recognize that 1 over x to the power of 4 is the same as x to the power negative 4. Okay, then the same law applies whereby power plus 1 divided by the new power and remember to plus c. Not forgetting to simplify our answer. This is a negative 3 in the denominator. I can put the negative sign up. 3 remains in the denominator. X to the power negative 3 needs to be moved down to the denominator. So we get the answer, negative 1 over 3x cubed plus c. Okay. then to integrate the cube root of x, again it is about applying our indices to recognize that it is integration of x to the power of 1/3, then power plus 1, divide by new power, followed by plus c. Okay. For powers, we don't write it in mixed number form. The reason is because we know that if the power is a fraction, the numerator and the denominator has its own implication. But by the denominator means your roots. Okay, so in this case it's a cube root and then power of 4. Okay, so powers we don't write it in mixed number. Always improper. But we need to handle the 4/3 in the denominator by simplifying it. So it is a division of 4/3, that is also 3x to the power of 4/3 divided by 4 plus c. Okay, so divide by 4/3 is the same as times 3/4. So that's why 3/4. Yourself too caught up in the formula over here. Okay, what it is trying to say is that if there is a constant, okay, that's multiplying a function, you can take out the constant before integration. So for example, okay, if we are integrating maybe 3x squared x, it is the same as taking out the constant first and then focus on integrating the x squared. Then we can apply our power rule here. Okay, to get 3x cubed over 3 plus c. Okay, so that is what the first property over here is trying to say. Okay. Then in the third property, what it's trying to say is that when you have two things adding up together, you can do the integration separately. So, in other words, okay, if you want to integrate x cubed plus x to the power of 5, you are just looking at integrating them separately like that. Okay? That's what it's trying to say. That's all. Okay. Then of course this one can continue integrate lah, but I shall not continue writing. Okay, so let's, yes, Jasper. Yes, so 3c long, yeah. But actually, right, c is just a constant. Yeah, if you want to maintain the idea of it algebraically, you can put 3c. But if you want to close the bracket here and put the c outside, that's fine as well. Okay, because c is just an arbitrary constant. Okay, it really doesn't matter, right? It will resolve itself. Okay, later on, if I really need to find the value of c. Yeah. Okay, so the bracket in this case is a special case whereby It really doesn't matter whether you put the bracket outside or the bracket inside. Okay? Okay, so then for part A, okay, in try 3, we want to integrate 5 over square root x. Yeah, that's one of the okay, sorry.
Other students, please head to Sinome later. Bring yesterday's worksheet, your Chromebook, and your stationery. Okay.
Aircon, very happy. Okay, so integrate 5 over square root x. Okay, so how we will do that is that we apply our indices law first. It is x to the power negative half. Okay, then we know that I can leave my 5 outside. And then focus on integrating by x to the power negative half. So in this case will be power plus 1. Okay, then divide by the new power. And that would give us 5 x to the power of half over half plus c. Okay, so we have 5 times 2 square root x plus c. Okay, because this is numerator, divide by half. Dividing by half is the same as multiplying by 2. Okay. Then if you want to expand it, it's also fine. You can write it as 10 square root x plus 5c. That's also okay. So something that we have not really touched on is how do we integrate a constant then? Okay, if you remember how we do our differentiation, if let's say I want to differentiate 3x, okay, I know that I'm going to get a 3, right? If I want to differentiate 4 over 5x, my differentiation is going to be a 4 over 5. So naturally, since integration is the opposite of differentiation, if I want to integrate a constant number, okay, what will become of it in the end is that I must have the x placed back. Alright? Okay, so therefore integrating 2/3 will be 2/3 x. Okay? Because actually it's x to the power 0 lah. Right? X to the power 0, then 0 plus 1 will actually become a power of 1. Okay? Yes.
For the answer, like 5c, the answer should say
yeah, as mentioned already, it's just arbitrary constant. It doesn't matter whether it's in 5c or d. It's just because the way I close my bracket. Yeah. Okay. So if I close my bracket like that over here, then it will just be a plus c. It doesn't matter. Yeah, acceptable. Okay. Yes. Yeah, I haven't finished yet. Yeah. Don't worry. Okay, so it will become 2 over 3x, and then we must remember to plus c lah. Okay. Okay, c is just a constant number. Okay, the value may differ depending on how we close our bracket, but you don't really have to worry about that. Okay. Okay, let's look at more questions. Try 4. Okay, so integrating negative x squared plus x. So as mentioned, okay, the property of integration is that if you're adding two things up, you can look at it separately. But you really don't have to be very clear about separating them out. Okay, in case you make some operation kind of mistake, okay, you just have to view it separately. Okay, in your mind, that will be good enough already. So when looking at integration of negative x squared, that means negative x power plus 1. Okay, followed by the other one, power plus 1. Okay. Because when you deal with it separately, then you have to introduce two separate constants. because plus C here, plus C again. Okay, and the constant actually by right should be different now. Alright, so that's why I don't recommend that you really write it out into two separate integrals. Okay, just do it mentally, then you integrate this, and then we just sum it all out with a single plus C. Okay, rather than having so many pluses. And all your plus C actually will differ one up. Alright? So just put it into one plus C is okay. Okay, then we simplify negative x cubed over 3. Okay, then that will be the answer. You find relief to know that when it comes to integration, there's no such thing as a product rule, quotient rule, and whatsoever. Okay, but that will also mean that when I have to integrate this, right? Okay, I must actually expand it because there's no product rule, no quotient rule. Okay, so no choice, expand this first, and then we simplify, and we get x squared plus 3x plus 2. Then we integrate. Okay, so I'm just going to skip a little bit of steps now. Not going to be so clear about adding the plus 1. I hope you get it by now. Okay, so power plus 1 divided by new power. Quotient rule, product rule. So even in differentiation, when you have something like that, denominator is a single thing, we try to simplify it first. Okay, so it will be 2x squared over x squared plus 3 over x squared, in case you don't observe that. So we're looking at integration of 2 plus 3x power negative 2. Okay, then we go about integrating 2x plus 3x negative 1 over negative 1 plus c. For our indices understanding, but never mind, we do it step by step. Okay, separate out into 2 separate fractions. Then, okay, we recognize that it is x squared. Denominator is actually x to power 1/3 because it's a cube root. Okay, so since it's dividing, so 2 minus away 1/3. Okay, likewise for the other one, it will be x to power negative 1/3. Okay, so it's somewhat a test of your indices understanding. Right, then simplify it first. 2 minus 1/3, that will give us 1 and 2/3, so that is 5 over 3. Okay, then we proceed with integration. 5 over 3 plus 1 is 8 over 3. Okay, make sure you distinguish your length of the fraction line. Okay, the main fraction should have a longer fraction line. Okay. And then since you're dividing by 8 over 3, it is the same as multiplying 3 over 8. So we get 9x to the power 8 over 3 over 8 plus 6 x to the power 2 third over 2. 6 over 2 can simplify still. So we have 3x to the power 2 third. Looking at try 5, part I asked you to differentiate. Okay, so at this juncture, differentiating should really not be an issue. Okay, so this is differentiating 4x minus 3 to the power of half. Bring down the power minus 1, so we get negative half. Followed by remembering to multiply by 4. Okay, so we get 2 over square root 4x minus 3. Okay. Then in part 2, they want you to integrate. But the instruction it says hence or otherwise, which means that you can make use of part I. Okay, we want to integrate 1 over square root 4x minus 3 dx. Okay, at this juncture, you will not be able to integrate something like that even if you were to express it as 4x minus 3 to the power negative half. Okay, so even if you re-express it to this form, at this juncture, with the skills that we have, we are not able to integrate this. Okay, so what we need to do is to make use of the differentiation in part I, okay, to help us to actually solve this question. So how will that actually work? Okay, we know that if I were to integrate 2 over square root 4x minus 3 with respect to x, that means that is your answer in part I. If I integrate this, I must get back to its original form, which is square root 4x minus 3. But I must remember the plus c. Okay? But then the question is not asking me to integrate this, the question is asking me to integrate 1 over that. But I know that in my integration, I can bring out the 2 and write it in this manner. Okay, where I bring out the 2. Then since my subject is actually to integrate square root 4x, like 1 over square root 4x minus 3, okay, that means I need to bring this 2 and divide it over to the other side. So I divide by 2. Likewise, my c will divide by 2. Okay, just to be accurate, if you want to re-express your c over 2, you can write it as another letter d, that's fine. Okay, so our constant itself, actually you don't need to use c all the time. Okay, so we can use c, d, you want to use a, b also can. Don't ask me why it's always c, probably because we know that it's a constant, so constant start with letter c. Okay, but letters that we cannot use to represent as constants are letters like e, I and o. number, your exponential number. I later on, if you want to do higher level mathematics in JC or if you do engineering for poly, okay, I is a complex number, it's an imaginary number. It represents square root -1, okay, and O because it looks like 0. Yeah, okay, so that one's straightforward. Right, so we avoid using EI and O as algebraic removals. Okay, so if you want to switch C/2 to D, you can, but you want to keep it as C/2, also okay. Nothing wrong with that. Okay, so let you practice now to get used to the concept. Okay, exercise 16.1, question 1, 2, 4A, C, E, and 5. Okay, can you work on these questions in your notebook now? I'll give you about 20 minutes, alright? Okay, 20 minutes should be more than enough. Okay, if you're still unsure of anything, please raise your hand, I'll come over to you. Okay? Wait up. Let's check our answers, shall we? Okay, in question 1, we are told to, rather both question 1 and 2, we are told to differentiate followed by integrating. Okay, so the differentiation that Amelia has given us is to differentiate x squared plus 5x, so we get this one as right. Okay, part 2, we want to integrate 2x plus 5, not forgetting to put in the dx. Okay, so that's very commonly left out. Okay, so we get x squared plus 5x plus c, which is the original function followed by the plus c. Okay, so our question 1 is correct. Then for question 2, to differentiate, we will have to do our quotient rule. Okay, so quotient rule application is done right, and then and then integrating your 2 over 2x minus 1 squared dx. There's a little bit of steps skipped over here, although yes, the answer here is correct. Okay, so in case you are not fast enough to realize how is it that this was arrived at, okay, it is to observe that this is equals to 2 times the integration of 2x minus 1 squared dx, whereby this part here is over here already. Okay, so that's why we get 2 times of this, okay, 2 times of this thing, and then followed by the plus c. Okay, because the integration here will arrive at x over 2x plus 1 plus c. Okay, so nothing wrong with leaving it as c. You can leave it as 2c, that's also fine. Okay. Then question 4, I think some of you had that problem when you were doing at first. So I hope you recognize that e squared is a constant number. It is no different from your numbers like 2, 3, 4, 5. Okay, so it will be just e squared with an x and then followed by plus c. Then for part B, the hint was to recognize that this is a number, this is a number. So I'm just going to shift it around by writing 2 ln 3 times x. Okay, then okay, what ellipsis has is that she took out the ln 3, okay, left the 2 inside, that's fine, nothing wrong, but usually we'll take out everything lah. Okay, but I guess the reason is because when she integrates x to get x squared over 2, okay, her 2 actually cancels out. So really up to you how you want to present your answer. Okay, if you want to write it this way, that's fine. Okay, however, a careful note is that if you write it like that, okay, 2 ln 3x squared over 2 plus c, not going to be correct. Why? That's because there's this ambiguity over here when you write ln 3x squared. Okay, it will seem as though the x squared is with the ln, is with the 3 and with inside the ln. It looks as though it's like that. But we know that it is actually 2 ln 3 as a number multiplying x squared, so make sure you have your brackets. Okay, to actually separate things out. Alright, so I think you should at least have this pair of brackets to separate out the number from the variable x squared. Okay, so be careful in your presentation. But anyway, eventually it simplifies to ln 3. Again, must have the brackets, x squared plus c. Okay, writing it like that has the ambiguity. Okay, so make sure have brackets. Okay. Then for part E, okay, so 2e times the x plus 1, okay, and then we get ex squared plus c. Yeah, that's correct. Okay, maybe presentation why we put brackets up. Okay, otherwise it doesn't quite make much sense. Okay, we are multiplying by a fraction. We put the brackets to showcase the fraction, the multiplication. Okay. Then for question 5a, remember dx. Okay, and then we have 2x followed by 3x power negative 1 over negative 1 plus c. And final answer, yes, it is 2x minus 3 over x plus c. Okay? Yep. Right? Questions? Okay, then let's move on. Okay, with the next rule. Okay, next rule is in terms of integrating ax plus b to the power of n dx. Okay, so it is actually a slight expansion from your, well, not say expansion, but extension from your first point, okay, whereby we will power plus 1 divide by the power, okay, but not forgetting that in our differentiation, we also will deal with the ax plus b. Okay, we will differentiate the ax plus b where we take out the a, right? Okay, so in our integration, we must also, okay, divide away the a when we do that for differentiation. So it will become plus c. Right? Points to note regarding this this integration rule is that it only applies when it is an algebraic expression that is linear, ax plus b. Okay, it cannot be ax squared plus bx. Okay, it doesn't apply. Okay, we don't have the skills at this level in secondary school for us to integrate this. Even if you ask me how to integrate this thing, I wouldn't be able to tell you. So, okay, I will probably need to go and Google it. Right? Okay, so the function itself cannot be ax squared plus bx, neither can it be things like your trigonometry. Okay, so sin x, cosine x, all that, there is a separate rule for it. Okay, it must strictly be ax plus b. Okay, so any other functions cannot. Then another important thing is that the power n, okay, cannot be equals to negative 1. Okay, why? That's because, let me erase this. We know that if I want to differentiate ln x plus 3 maybe, okay, we have already learned how to differentiate ln. What we're going to get is 1 over x plus 3. Okay, so when I want to I keep on mixing up my integration and differentiation. So if I want to integrate 1 over x plus 3, which is actually x plus 3 to the power of negative 1. So if I want to integrate this, I should be getting ln. You understand? Okay, which we will cover it later on in this chapter. Alright, so that explains why our power in this case can be any number except n equals to negative 1. Because when it is power of negative 1, we should be getting ln. Okay? And so let's practice some examples. Power of 4, using our fourth rule which we have just learned, okay, is that we will get power plus 1 divided by the new power, and remember to divide by the coefficient of x, which is 2. and then not forgetting the plus C. Okay, so we will get this as an answer. Then for part B, to integrate 1 over 3x minus 1 to the power of 3, we re-express it into a power of negative 3. So power of negative 3 can be integrated, okay, with our rule over here. It is only a power of negative 1 that we cannot. So we will have 3x minus 1, minus 3 plus 1 is minus 2, over negative 2, times 3. And that will leave us with negative 6 times 3x minus 1 squared plus C. And if I were to integrate square root 5 minus x over 3, I will be looking at integrating 5 minus x over 3 to the power of half. Half plus 1 is 3 over 2. Divide by 3 over 2. And then recognizing the constant in front, or rather the coefficient of x, which is negative 1/3. So that's why it's a negative 1/3 to be placed here. Then plus C. Okay, 3 over 2 times negative 1/3 will give us negative half in the end. Okay, which is actually a multiplication of negative 2. So we get this answer. Okay, let's just do one more and then we call it a day, okay? Okay, so to end off our lesson today, let's look at knowing how to integrate x squared plus 2x over x squared plus 2x plus 1. Okay, the challenge in this question is that we don't have a quotient rule for integration. Okay, we are only limited to this set of rules when it comes to integration. Okay, so how will we deal with this? There's also nothing for us to simplify. You cannot cancel away the x squared, cannot cancel away the 2x. Okay, so there must be a way to get out of this, and that will be to consider separating out this fraction. Okay, so what you can consider, okay, is that in the, okay, hang on, okay, so what you can consider, right, sorry, I just thought of another way that might be easier for you all to do, okay, maybe you can do by partial fraction, okay, which is a skill that will be needed when we do our integration. So especially when later on we learn how to integrate logarithm, okay, we must know how to do our partial fraction. So in this case, we see that they are of the same degree. Okay, numerator and denominator both degree 2. Okay, polynomial. So that means that I need to do my long division, right? So I will be getting x squared plus 2x divided by x squared plus 2x plus 1. Agree? Okay, trying to help us recall our long division. Okay, so x squared plus 2x down to x squared plus 2x also, we are just going to multiply by 1. Okay, so we are going to minus away the entire x squared plus 2x plus 1. And now we will be left with a remainder of minus 1. So therefore, in integrating this, our fraction here can be re-expressed as 1 whole minus away the remainder, okay, and then the denominator, like that, right? Okay, but we'll still be posed with a challenge, because even if I were to re-express my x squared plus 2x plus 1 into something like x squared plus 2x plus 1 to the power negative 1. Okay, I still cannot integrate this because, as I mentioned, in order for us to use this rule over here, the inside must be linear ax plus b. This is quadratic, so it will still not allow us to apply our laws over here. Okay, so what we need to do is to observe that x squared plus 2x plus 1 is actually factorizable, if there's ever such a word. It is x plus 1 squared. Okay, so this explains to us why we must know how to factorize, don't just rely on calculator. Okay, which is what many of you like to do. Okay, so x squared plus 2x plus 1 can be factorized into x plus 1 squared, which then allows us to use our rules. Okay, since inside now is linear, so integration of 1 is x plus 1 to the power negative 2 will then be power plus 1 divided by power divided by coefficient of x, which is 1, followed by plus c. Okay, then we will get minus minus become plus. Okay, then this one goes into the denominator. And not forgetting plus c. Okay, so I'm really trying to get us to recall our partial fractions. Okay. Now for tomorrow's HBL lesson, okay, I'm still a bit undecided about what to do yet. Okay, so look into your Google Classroom tomorrow. Okay, and then after that look out for the instructions. Right? I might, okay, maybe not do the application part for 16.1. Okay, might ask you all to do an SRS lesson on integrating trigonometric functions. So we develop those skills. Okay.